Hi, my name is Shadi Atia, professor at Liège University in Belgium, and today's presentation is about the design of experiments. Today's presentation is part of a playlist on experimental research, and in the previous presentation I was talking about statistical analysis, which is a very important presentation as an introduction to today's presentation. The audience of today's presentation is mainly postgraduates and scientists who are conducting or seek to conduct statistical design for their experiments, and they are looking to screen the parameters that they want to test and at the end optimize a product or a solution or a certain problem. Also, the audience is mainly medical sciences, people working in the field of medical sciences, social sciences, life sciences, and natural sciences, including engineering. And the presentation also is for mentors and supervisors. This is the most common slide that I use in my playlist on experimental research. As you know, there is 3 approaches of research: quantitative research, qualitative research, and mixed research. We had a playlist on qualitative research, and we are today giving a presentation on design experiment within the research methodology of experimental research. So allow me to share with you the objective of today's presentation. Actually, the objective is to enhance your capacity to design your experiment and understand the optimal or the best design of experiment to assure a powerful investigation technique. And keep into account here, I'm trying that you avoid the trial and error experimental testing, and I'm trying to help you to do multifactorial experimental testing, but this requires that we do first statistical preparation for the combination and the possible combination of your experiment, and you make sure that you design that so that when you go conduct your test, you have the minimum running test that you need and with the most effective findings. Now, what I'm going to talk about today's content, I'm going to talk about what is the design of experiment, a general introduction, how to determine your interactions and factors and levels of intervention for your experiment, what are the types of investigation of the design of experiment, and then I will talk mainly about how to screen your variables or your factors, how to characterize your test, and finally how to optimize before coming with a checklist and a takeaway message. So let's start with the introduction. What is design of experiment? Well, design of experiment, it provides a structured way to design and conduct experiments. Design of experiment includes a series of applied statistics tools used to systematically classify and quantify cause-effect relations between variables and outputs in the studied process or phenomena, and it allows us to screen many factors to determine which are worthy of deeper investigation before even conducting the experiment. So it's a very intelligent way and a very useful tool to inform the experimental design process and to make sure that before you run your experiment and start to do all this laborious work and all this time-consuming and very costly testing, that you first define what type of tests with which type of intervention and factors that need to take place. So it is a branch of applied statistics, and it is mostly used in material science, agriculture, medicine, chemistry, biology, marketing research, or industrial production. It's also used a lot for optimizing products. Now, design experiment, why do we use it? Like I told you, it's a widely used statistical method applied in different fields of science and industry also. And the design of experiments support the design, development, and optimization of a product or a process or a solution that you are looking to improve. So in this sense, we are avoiding the trial and error approach while adopting an informed approach, which is very effective because you will reduce the time of your experiment, you will reduce your number of your experiment, you will go directly to the point. And if we look at an earlier publication by Berton Gunther, he says that scientists who ignore the statistical design of experiment risk working at reduced efficiency and forfeiting valuable experimental information. And this is a luxurious situation that nobody has. Today, accessing labs is very complicated, very difficult, very costly. So you have to do a design of your experiment and make sure that you will identify the factors and the potential correlations before going with the experiment so that you run the minimum number of tests with the highest potential of tracing change or variability and maybe correlation so that you can really stand on the cause-effect relation and make sure that what you are testing is beneficial to the optimization question. Now, before going further, I need to talk about factorial design. This is part of the introduction because many people don't know what is factorial design. Factorial design is simply allowing us to study the individual effect of all intervention as well as the interaction with others. So it is a multivariate approach that allows to have a more complexity in our testing of the cause-effect, and it does allow us to go beyond one single independent variable and one single dependent variable. A factorial design can have a number of groups and variables, and it is not limited to any combination or interaction in the domain of possibility. So here, when we look at the domain of possibility related to a problem or a product or a subject, we can have a broader solution or combination space, and the design of experiment will allow me from this different combination and different possibility to narrow them to the minimum number of tests with a high chance of probability of interaction. That's what I'm looking at. And why do we do that? Because actually we have to directly start by screening all these factors, because we don't have the time to start to do huge combinations of interactions between the factors that might influence our problem or our solution. So we do first screening through the statistical testing or through this design of experiment. And when we reduce these factors that potentially might have influence on the quality of our final solution or product or process, we start to conduct and advise to conduct the real experimental work, and then we can come up with the full factorial analysis that will allow us to do the optimization afterward. Now, what is the original of the design of experiment? Well, this methodology, which is a pure statistical methodology for designing experiment, was first proposed by the British statistician Ronald Fisher, and in the arrangement of field experiment 1920 and the design of experiment books 1935, he explained this methodology. And the design of experiment is developed primarily for agricultural purposes. At that time, there was different combination varying the crops, the fertilizers, the watering, the nature of soil. You see so many different factors around one phenomena of, for example, yield or high productivity agricultural production. And Fisher was concerned of not spending so much time on the field with experiments that are useless, so he was developing this approach. So he mostly worked on how to apply statistics to agricultural research, and he is the inventor of the famous ANOVA and the design of experiment statistical tests and methods. So it's important to take this into account. Now, when we look at the characteristic and principle of the design of experiment, a good experimental design ensures the validity of the given insight, and it is unbiased. So we need to make sure that we have randomization and blinding, and it has to be highly precise, looking at uniform material, replication, stratification, simple to protect against mistakes. Also, a good experiment must have a wide range of application so that we deliberate the variation. We have a factorial design to select the tests and be able to estimate the uncertainty and the confidence interval, the range of error through randomization and replication. So this is also to take into account that a design of experiment is seeking excellence and high confidence in reducing the uncertainty. Now, the first step that you will need to do when you will design your experiment is to determine the interaction, the possible interaction between your factors and your levels. And allow me to explain further what is the factors that you can use in your experiment. What is factorial experiment? In statistics, a full factorial experiment is an experiment whose design consists of two or more, minimum two or more factors, each with discrete possible values levels. And here there is an example. For example, I have a discrete factor that I am testing not drinking caffeine, drinking 200 milligram of caffeine, drinking 400 milli of caffeine. This is this is a factor on two levels, one for people who have alcohol consumption and people who have no alcohol consumption. So here I have two factors and two levels. So you can see here this complexity, I cannot do it easily with the classical statistical test. What are the study factors here? I look here at independent variables that are referred to as factors. So now here I will not use anymore the word independent variable, but I use the term factors. And one independent variable, you need to have one factorial design if you have only one independent variable. But if you go for two independent variables, then you have a two-factor design, and so on. With three independent variables, you have three-factor design. So in this sense, you investigate whether the independent variable is influencing your measurement or not. The second important term that you need to know when we are talking and defining our design of experiment, once we define our factors, we need to define our study levels. And what are the study levels? It is the number of groups or conditions for each independent variable. So if I'm looking on the influence of not drinking caffeine, which is one factor, on people who have alcohol consumption and people who have no alcohol consumption, then I have here one factor, two levels. Level 1 is alcohol, level 2 is no alcohol. This is the first factor. The second factor is drinking coffee, 200 milligram for people who consume alcohol, people who don't consume alcohol. And then I have 400 milligram caffeine for people who consume alcohol and people who don't consume alcohol. So in this sense, I have 1, 2, 3 factors, and I have 1, 2 levels. My three factors are no caffeine, 200 milligram caffeine, 400 milligram caffeine, and my levels are a group of people with alcohol consumption and a group of people with no alcohol consumption. So this is an example that shows the complexity and that I go beyond a single independent and dependent variable correlation. I'm going now to multifactorial or multivariable correlation with a huge space of combinations and different interaction. And here comes the importance of defining the factors of your experiment and the levels of your groups that you will expose or have your intervention exposed to. So what is a factorial experiment? Well, I mentioned before, any statistical test will have factorial factors, and it will have more than one factor and more than level. We will have independent variables that are referred to as a factor, and we have a factorial experiment that is involving two or more independent variables. But when we go further into detail, definitely a factorial experiment is not a trial and error experiment. I'm not going now to test all these variables of my different interaction and or combinations, because I have a possibility, I have a space of possibilities of combination between my factors and my levels. I do not have the luxurious time and cost and effort to go test all these alternatives. Now I need to do a factorial experiment, which is totally opposite to the trial and error, and it's totally opposite to the one factor. I need to do factorial design. What is factorial design? As you can see, I need to define my combination space with full factorial approaches. For example, I will have 3 variables or 3 factors and 2 levels. The same example that I mentioned, 3 types of consumption of coffee against 2 levels of alcohol, people consuming alcohol groups. And I can, based on that, define the chances of combination that reduce the possibility, but with the highest potential of having a positive hypothesis. So what are the key steps to perform my design of experiment? I have to define very clearly my objective of my experiment, define the response variable or my dependent variable that I am investigating in my work. I have to determine the factors or the independent variables that I want to investigate or I'm investigating, determine your levels, start your experimental design, define your experimental design type, and then start executing your experiment, and you can by now do your data post-processing and visualize your results. So those are the main steps of the design of experiment. Now, what are the 3 types of investigation that we use when we conduct the design of experiment? We have 3 types of investigation that we conduct the design of experiment. The first step is the screening. I need at the beginning of characterizing my experiment and defining the factors and the levels that influence this complex phenomena is to do a screening design. And in this sense, there is a series of tests that can be conducted to reduce the range of combination and reduce the factors and the levels to the essential. And to do that, we need to do screening designs. And here we are looking to maximum 6 to 11 factors, okay? Once we are done with the screening, we can move to the characterization step of my design of experiment. All that I am doing it on the statistical level. So here I reduced, after screening the 6 to 11 factors, I reduced them and I figured out that some of the factors are not so influential, so I came up to characterizing 3 to 5. I get more into detail and I do some basic tests to understand their reactiveness and their impact or their influence on my final solution or outcome. And once I characterized 3 to 5 factors, I can start to focus on optimizing only 1 or 2 factors by repeating my experiment and varying only the properties or the characteristics or the features of those 2 factors. By now you see there's a funneling effect. I'm narrowing down so that when I reach the optimization step, I only work with 1 or 2 factors that I found from the screening the most influential and from the characterization. So here, these are the 3 steps of the design of experiment, and it's so powerful statistical method because instead of being lost investigating on different levels of factors up to 11, you will reduce them to 3 to 5. When you do the characterization, you will know more about them and better about them, and you reduce those 3 to 5 to be only 1 or 2. And once, I can promise you, once you have only 1 or 2 factors in your lab and you are investigating, you will be much more effective in producing your results. You will be very straightforward, short time, and you will have promising results because you have already funneled or reduced the factors and reduced the level for your experiment. Now, what are the most common design of experiment methods? Like I told you, if you imagine that we have a domain of possibilities with different combinations and different interaction between my factors and levels, in this sense I can do different types of tests to focus on the most essential type of combinations. I have full factorial testing, I have fractional factorial, I have central composite approach, the Box-Benken approach, the D-optimal design, and the very famous Taguchi design. Those are designs, tests, statistical tests that will allow you to create or select from this huge domain of possibilities the most relevant combinations and interaction that might have a promising result on your final solution or your final product or your final process. So in this sense, you have to master or learn about these methods after you have defined your factors and your levels. Another type of design of experiment methods that are commonly used, we have Taguchi 2 levels 3 factors, we have the Plackett-Berman design, we have the definitive screening design, the DSD, we have the Taguchi with 2 levels plus 4 levels multiplied by 2 factors, which is the L16. We have the Taguchi L18, which is 2 levels plus 3 levels multiplied by 2 factors. And we have the Taguchi L32, which are 2 levels plus 4 levels multiplied by 2 factors. You see the level of complexity and the huge combination space is getting larger and larger, and those all tests will help you to select representative combinations and interactions so that you don't test the whole combination space, which is impossible. You will just have representative combinations and interactive, and instead of running thousands of tests, maybe you end up running hundreds of tests, and this is here the added value. So let's go to the first step, systematically. What shall I do in a nutshell? First of all, you have to seek screening and characterization. How to do that? Well, screening is to discover the few primary factors that drive the process or drive the product. Screening designs takes advantage of few assumptions that systems are dominated by the linear effects And third and higher order terms are not necessarily over reasonable factor ranges. So this is important. And when you start your screening, you have to be already defined your factors and your levels. This is, for example, a template for the design of experiment. As you can see, you have your problem statement, you have the objective of your experiment, you have your starting date, and so on. And you are listing here all your factors you're looking at, the range for your factor, the levels, the anticipated interaction, and how you measure them. So this is a very important template to start to answer a lot of questions, and you must start by filling this template to get to the core of your experiments. What are the screening methods that are most commonly used? The most famous one is the definite screening design, the DSD, and the DSD can address the possibility of two-factor interaction and quadratic effects without additional run. So you can start with the DSD. Also, you have the Plackett-Burman design, which is the PBD, which is a particular type of fractional factorial design, which assumes that the interaction can be completely ignored and the main effects can be calculated with a reduced number of experiments. So once you are working with those two methods, you can start the screening process. And the third famous method within the screening and characteristic approach is the Taguchi design methods, which are variant. And the Taguchi design method rely on orthogonal matrices where factor levels are distributed in a balanced way. Some of the method is suitable for screening. For example, if you are doing two-level Taguchi design, and other factors are more in-depth characterization if you are doing optimization or characterization. So it's important to take this into account. And once you have defined your factors, your level, you can start to use one of those three. I advise always to go systematic, try the DSD. If you have, you can use also the PBD, and then you try also the PBD, but the very simple one, which is the two-level Taguchi design. And once you are going through with your testing, you can start to define what type of experiment that need to be conducted. Now, the second step after you have screened and characterized your sample, you can start working on the optimization. Now you have conducted a series of tests, you screened the different factors and your levels, and you eliminated a lot of non-relevant factors and levels of testing or groups. Now you are moving to the point of focusing on one or two maximum factors that you will continuously vary their input to check the influence on the product or result or solution or process that you are investigating. What are the optimization methods that are commonly used? We have the response surface method for experimental research. We have the Taguchi L32 design of experiment, and we have the central composite design, and we have the Box-Benken design. Those are the most famous for optimization techniques in experimental research, and definitely I will not explain each of those in this presentation. You will need to seek further training on that, but those are the four mostly common techniques, and from there, with these four methodology, you can keep optimizing only one or two factors until you reach to an improvement, a significant, remarkable improvement regarding your product, solution, or others. So I'm coming to the end of the presentation. A checklist I want to share with you regarding the design of experiment. Design experiments start with brainstorming session. You have to, and in the brainstorming session, involve experts, involve your promoter, involve senior researchers who conducted previously experimental research, and they have a kind of familiarity with the nature of the problem. Design of experiment is a very advanced technique of statistics. So if you are not, if you are a beginner, you need to have experience to be able to do it. You need to have resources, you have to have training. Perform after you are having your brainstorming and you made sure that on the table are the people who know what they are talking about, and you defined already the objective of your research, and you characterize basic some factors and levels for your experiment. You can start to perform your screening for your experiment. You can start with small experiment and small samples to understand the process, and this is what we call the pilot. Do some pilots to get more familiar with the process. Start your statistical analysis as early as possible and get familiar with the ANOVA test, because from the ANOVA you will track or detect variance, and once you have variance, you will continue with the factors that can lead to variance, and once you have no variance, you will eliminate factors or levels that cannot lead you to variance. It's very important. Disqualify the insignificant effect, as I mentioned, due to the ANOVA test. Randomize and replicate your experiment to make sure that you are avoiding any bias, any error, any uncontrolled influencing factor, and finally report the error of probability for all your tests. Voila. This is the end of today's presentation. Some takeaway message. Today we talked about the design of experiment, and we mentioned the screening design test in the design of experiment, which is the definitive screening design, the Plackett-Berman design of experiment, Taguchi L16 and L18 design of experiment, which are two-way testing, very simple. Now, once you're done with your screening, you can characterize with more focus on certain specific factors. Here we are talking about 3 to 5. You can use fractional factorial design of experiment, full factorial design of experiment, or again, you can use Taguchi level 16 and level 18 design of experiment. Once you are done with characterization, now we know which kind of factors you will follow till the end of your study, mainly 1 to 2 factors. Here you can start to do more advanced statistical analysis to select and improve or optimize your process and make sure that you can have a different influential variances on the combinations of your interactions. You can do responsive surface method of the design of experiment. You can do the Taguchi L32 design of experiment. You can do the central composite design and the box Benken design as approaches for optimizing your design of experiment. What was today's presentation about? The goal of the design experiment is to minimize the number of trials while having a representation as accurate as possible. So therefore we needed to do screening, we needed to do characterization of the most influential factors, and we need to focus on optimizing 1 or 2 final factors till the end of the experiment to make sure that my product, my solution, my process has been significantly improved. Then I have to look at that an excellent design of experiment differ in efficiency. For example, this means that the ratio between extracted information from the examined process and the invested resources is logic. It's not normal that I go have a lot of investment, a lot of effort to seek testing different combinations while their variance is not so important. So it's very important to look at that. And the design of experiment is about selecting the right design, which means identifying the best way to sample the domain of possibilities and interactions between your dependent and independent variables in your experiment. And you have to indicate the appropriateness of each statistical test and fully report the outcome to make sure that you are not making mistakes with your selection of your testing. And for sure, I advise you to seek training courses that are more specific and more technical regarding the design of experiment. However, today's presentation gave you an overall idea why we do the design of experiment, how we do it, what are the most famous experimental methods that are used, and from there I hope you can continue with conducting your experimental research. Well, this is the end of today's presentation. Don't forget that this presentation is a part of a playlist on experimental research. I hope you watch previous videos and future videos. Don't forget to please share this presentation with anybody who might be potentially interested or having a benefit from this presentation. Don't hesitate to comment on this presentation. You can complete anything that was missing, any error I made. I'm fully looking forward for your input, and thank you very much for your attention, and I hope the best of luck with you with your experimental research. I think after this you are ready to do your experiment. Thank you very much.